Okay, guys, I'm gonna help you out here with determining the constant rate of change. I'm getting this from page 191. Okay, 191. I'll do a few of these. So remember, the rate of change is just think of this. Remember the change in the y's over the change in the x's. Okay, remember this means change. So change in y. So just remember, this little triangle means the word change. So change in y over change in x. What I mean by the change is on a table we can look for a pattern. Okay. Now we have to distinguish, okay, who's my y variable, who's my x variable. So remember, this is your y variable and this is my x variable. And so now think here in the table, who is my x, who is my y? Well, if you can't stop time. Time will continue whether you want to or not. It's going to always continue. And so that means time is independent. Distance is your dependent. So that's why we put here, okay, the change in the y's is your y variable. So these are the y's. And the x's are the time. The pattern we can find by, okay, what is time going by? How much are we going by? Well,
Oscar Castillo, report to the office. Oscar
Okay.
Castillo, report to the office.
we're going in time in seconds and we're going by ones. The pattern is 1. And then the distance is in miles. What am I going by? Well, I went from 6 to 12. That means 6. If I add these two together, I should get 18. And I do. So it's going by 6. 18 plus 6 is 24. So I get 6. And so my pattern, my change in the y over change in x, means what is the pattern in the y's over the pattern in the x's. We already said distance is the y's. So this would be your change in the y's, which is the 6, and the change in the x's, which is the 1. And so this is my rate of change. And this is my rate of change. It's also your unit rate because it has a 1 as a denominator. And what does it represent? According to my table, it means that I can do 6 miles in 1 second. Okay, so the answer would be, okay, 6 miles in 1 second, which is my unit rate or my rate of change. Number 2 is the same thing I did for number 1. Just follow the steps. Okay, number 3 there, you have a, not yet, in a little bit, not yet.
Not yet?
Not yet.
Okay,
Yeah.
but I'm gonna tell the teacher, okay?
Okay, all
Like,
right.
I'll tell her.
All right. So here, on this one, on a graph, all you gotta do is pick 2 points, okay? Now there's a shortcut, yes, but you have to figure that on your own. But if not, pick 2 points, okay? I have this graph. I'm gonna pick 2 points there. I'll pick this one and this one. Okay, I'll pick those 2 points. I'll pick 3 and 27, ordered pair. Okay, got it. And 2 and 18. So I have 2 and 18. Okay, and so I have those 2 points. And I'll put them next to each other so you can see. Okay, so 3, 2, 18, and 3 and 27. I got it from here, okay? All I did was pick those points. I know the first number is your x variable and this is your y. It's an ordered pair and it's always x first and then y. So x variable, y variable. Okay, so how do we figure out what the rate of change is here? Or the rate, remember the rate of change is your change in the y's over the change in the x's. Change in the y's over the change in the x's. So let's look at these 2 points. Well, how much is my y's changing if I went from 18 to 27? How much of the y's changing? Well, if you get the difference, the change means subtract. So 27 minus 18. Okay, so I'll put here 27 minus 18. We regroup and we get 9. And so my rate of change here, the y's are changing by 9, And then how much did the x's change? And they changed by 1. And so this is my rate of change. Well, what does it represent according to my graph here? And what does the 0 represent? Well, it represents the origin. But what does it represent according to the graph? What am I talking about? Look what you're talking about, cost and number of shirts. So this is the rate of change. Well, what does it mean? What are we talking about? 9 over 1. What are you talking about? What is the 9 and what is the 100%? Okay, you got to tell me that. Okay. Number 4, we did an example in class. The same thing. It's like number 1, and it's like the one I just did right now, number 3. So you're comparing and see which one answer the question it gives you. Number 5 there, at 1 p.m. So let's put there, at 1 p.m. the water level is 13 inches. Okay. At 1:30, the water level is 18 inches. And at 2:30, the water level is 28 inches. What is the constant rate of change? In other words, this word here, constant rate of change, let me underline it. What is the, they could ask there, what is the unit rate? In other words, how many inches in
Oscar Castillo,
an
report
hour?
to the office. Oscar Castillo, to the office, please.
How many inches in an hour? Well, look from here to here. From 1 p.m. to 1:30, that's 30 minutes. So what was the change? From 1 p.m. to 1:30, that's 30 minutes. From 13 to 18, that's 5 inches. So kind of think about that. 1 p.m. to 1:30 is 30 minutes. 13 inches to 18 inches, that's 5 inches. Okay, and try to figure out the answer. Okay, think about what I just said, and hopefully this helps you. Hasta mañana.